All right, hello, everybody. My name is Maddie. I'm here from AMD. This talk that I'm going to present right now is supposed to be our vice president. Ramin prepared it, but he couldn't make it, so they asked me to present it. So originally, I was going to just do the hands-on workshop that is coming in about 10 minutes, along with my colleagues. But I will first cover the presentation that Ramin prepared, and then we'll get to the hands-on workshop. Just a couple of notes about the hands-on workshop that's coming up soon. It will be basically on your own device. So if you have your laptop, it'd be great to connect to Wi-Fi, prepare. My colleague's gonna pass you guys that are in person a piece of slip that will have a URL that you can basically access that environment we prepared for you guys. I would ask you to hold off on doing it and do it right after the presentation, but just be prepared for it. Okay, so the topic that we prepared for you guys for this talk is about how the measure of work is changing, and we're going from tokens to outcome. And before we all so obsessed with tokens per second, and now it's going to cost per finished task. This is going to happen through our most recent work with the latest model from Moonshot AI, so Kimi K3, where we basically work with them to make sure we have day zero support. So we go through how this whole thing is changing within the data center and AMD. All right, to start with something that sounds obvious and is going to turn a little bit expensive later, is when you think about AI chat, in terms of how it works, it's basically a bounded task. So you have a user, sends a prompt, you get the response as human, you read it, and it's done. But when it comes to agentic AI, it's a bit different. It's not bounded anymore. So you basically have that same query going there, but the agent plans, maybe does some tool calling, it looks at the result, maybe doesn't like it, calls the tool again, maybe starts a whole graph engineering loop of agents to go through it. And now the same sort of work could be seconds or it could be hours. So how is this changing things for us? It basically means at this point that from outside view, when you're planning things for in terms of capacity or how much of budget you allocate for your team, it's a lot different now, because now before you basically go for the seats and have users assigned to the models or service, but now one user could take a few seconds to get a response, one user could be hours. And that's a whole new magnitude of difference between the amount of compute that's needed for each of those tasks. This way of the change that is happening is going to break a few things. So 3 of them that we highlighted here are first, budgeting. And I think this is one of the reasons my VP put there, because I believe in the beginning of the year we were budgeting for the whole year of compute for our team, and we blew through that within a few weeks. And this is happening across the industry. So 2 people using the same service, one person could be 10 or 100 times more expensive, given that task might require hours of loop through agents. The second thing is, before we were all very obsessed with flops and tokens per second and how GPU is fast enough to handle those tasks, now it's a bit different. So the context is growing so fast with the whole multi-turn agent runs that it's now the whole system. Now we need to optimize the system a bit differently because there's a lot of memory bound now. And in terms of the scorecard, again, tokens per second was what we were obsessed with, but now it doesn't tell you much about how much compute is needed. It's because it's about the finished task. It's not just about one response. Okay. So all of them I'm going to talk about is about the same principle, which is, in short, is caching. Every turn repeats work from the last turn that already did. So if you think about the context, in a loop of agent, you have, on the 12th run, you basically need to still compute all the 11th runs that you've done before and move on to the little bit left on the 12th one. But the obvious answer is, why don't we redo the calculations that we already done? So we should keep it. And this is something that we've been discovered and done for the past previous years. But now it's a bit changed. So the whole way that we do this is across 3 different silos. So we have it done in the models, we have it done on the GPU stack, and also on the CPU. So all these 3 in parallel are working to make sure we don't hit that memory band problem. So let's get started with a few quick examples of how this happened with our Moonshot AI collaboration for Kimi K3. The first one is in the model point of view. So the problem is that KV cache grows rapidly. So every time you get a new response, it grows and grows and grows. That could be very large for very large models. It could get to hundreds of gigabytes. And you can't keep all of that in your memory, especially HBM, the fastest memory for GPU. So what they've done with Kimi K3 and all the models that are basically in the past few years, they tried to optimize that. And the very interesting thing about Kimi K3 was they actually went, out of the 93 layers, 69 of them are based on this whole new concept of KDA, which is Kimi delta attention, which basically it uses linear attention with recurrent layers. So actually you have a fixed amount of tokens that are being computed for those layers. So in our experiment on AMD MI355 GPU, which one node has 8 GPUs, each of them 288 gigabytes, it only was about 15.5 gigabyte of memory. So that's a lot smaller, better for us to compute. Okay, next is the GPU serving stack. You can't basically have a very feasible data center when you have that cache for every request be saved in HBM. So with the new model from Moonshot, we basically went through the whole redesigning this in terms of the tiered caching. So what we have right now is HBM. Under it, you have your basically it will be HBM, then you have your DRAM from the CPU, and an SSD, and under that you have the pool memory. So all of these together basically creates these tiers. And the whole point is when you have an agentic run, the agent basically runs a task, it waits for the results to come back, so whether it's a tool call or whatever it's done on the CPU, there's a lot of idle time. So when the eviction happens, you want to make sure that GPU is still busy and it's being used. So a lot of that cache sometimes gets evicted. With a tiered way of how we've done it now, you basically have it ready, the prefix is ready for you when the model is ready to run the task. So that's how we went from typical on the 99th percentile, where we used to get, with the previous method of 17.3 seconds down to 5.4. That's 3.2 times faster than before. On the CPU side, again, with agentic AI, the CPUs become a lot more relevant. We have a lot of compute happening there, and that's where we can talk about how the tools can be called more efficiently, how the CPU execution can be a lot more efficient. And one good example is the tokenization part of it. So you can also cache that, and this is another example that we're trying to show that if you just basically cache what's new, you kind of get a flat rate of 0.09 milliseconds compared to recomputing the whole thing that is 1.7 seconds. So we also get a lot of compute efficiency on the CPU side. And we wanted to also include this part that basically might sound a bit confusing for some people that, how the numbers and the amount of work that you calculate is changed. A lot of people report the hit rate for cache, but you can see here in this example, you go actually a lower cache hit rate. So you went from 88.5% to 87.5%. So when you look at it first, you're like, wow, this is worse. But the reality is, we talked about the time to first token previously when I said 3 times better. And actually, that's what we measure now. So it's about the successful run, because that 88.5% doesn't mean a lot if you still have to compute the first token, so you have to go a lot longer experience. So at the end, the user gets a better experience with lower cache hit rate. So you still have, better experience, but the whole problem is we need to report cost and time per successful run, not just tokens per second and those measures that we used to do before. And this kind of concludes the first part of our presentation. So the winner is whoever finishes the most tasks per dollar. And things are changing for AMD, and it's moving forward to a different direction, and we're going to see more of that. So thank you for this part of it. We're going to quickly move to the workshop side, which I don't know if you all got the piece of paper. Did you? You all have it? OK. So this part is going to be a hands-on part. I'm going to be doing it with Satya. This is, I think, a great experience because you get to also see how you can run your agents efficiently in a hybrid manner. So along the same theme as what I was talking about so far is about efficiency, saving tokens. And this workshop is basically going to use OpenClaw. How many of you guys have ever used OpenClaw, by the way? A few? All right. So you're going to be exposed to OpenClaw, but we're not going to do a deep dive on OpenClaw. It's more of how you can actually have the agents be able to decide on model usage. So we're going to kind of cover a mixture of models. And this is the theme of the workshop to save you guys token in terms of cost and privacy and efficiency. One thing to make sure we cover here for all the developers, there is content such as this that I'm going to present today and free compute with free AMD developer program. You do get a bunch of benefits that are listed there. I'm not going to go through all of them, but basically free courses, free GPU credits, free giveaways that we will send to the lucky winners every month. This is a link for the people attending virtually. As I mentioned, please go into this link. You should be able to see a new card added for you guys, request even credits. If you fill that form, we will be able to email you with a unique link within the next few days to be able to follow the same workshop we're doing today. About us, my name is Maddie. I just introduced myself earlier. Satya is my coworker within the same team. And we have Ida in a lobster costume, but on the side right now, so she's the one that's going to support us on the side. So she's one of our TAs. We have a few TAs here. If you run into any problems during this workshop, please put your hands up, and we'll have one of the TAs to come help you. Again, the theme, don't compute what you don't need to, and also focus on privacy, security, and efficiency. A lot of what we're going to talk about today is about routing, right? By default, when I bring up the routing to a lot of people, developers, the first thing they think about is routing inside the model. And that's the idea of MOE, a mixture of experts. Just to cover a little bit of background, the whole idea of routing, one of the notable papers was from 1991 from Jeff Hinton and his team, where they actually explored this idea. But that was early days where the compute was not as strong as right now, and the models were a lot smaller. They came back to the same idea in 2017, and they basically explored it for a much bigger model. They went, I think, to a model, if I remember correctly, over 1 trillion parameters, and discovered more throughout there, such as sparse gating and how they can actually have a better expert selection through the gating algorithms they had. And this is continuous. So you see more and more MOEs coming, and it's more of a state of the art as of right now. But the same idea of routing could be applied to models. So instead of having the expert to be what you route to, you can actually have the models to be the endpoints. And today, that's what we're going to cover. We're going to basically have a model that's running on a box that is just like this. It's in a data center. Might be a slightly different form factor, but the same sort of compute. So this is the AMD Ryzen AI Halo box. It's available in the market to purchase. Basically has a very strong CPU. You can run model locally. We're going to show that quickly in one of the slides. But that's what you're going to be using to run the local model, and you also have a cloud model. The point for that is the 3 pillars that I've shown here. You can actually save a lot of money on the cost because not every token deserves that best frontier model out there. If, for example, you're looking for a file or looking for a simple command, you don't need to send that to your Fable 5. In terms of quality, you can escalate when it's needed and also have some specialized model to handle those tasks that you can get done with a specialized model. And finally, privacy and security. I have a lot of personal files on my computer, and I don't feel comfortable sending that to cloud. I don't want my social security number to show up somebody's training data, so maybe that's a better idea to keep it locally. The idea that we're going to present today about mixture of models is not our idea. It's been something that have been explored in academia. In 2023, for example, there was a paper, Frugal GPT, that came out, and they showed how they can actually have a one model that basically judges the response that goes to the small model. If they're happy with the results, they just keep it. Otherwise, they escalate to the cloud model. So that's like one idea was explored. And they showed it can actually save 98% of total cost by doing so, and got very similar results to GPT-4 at the time. The idea was again explored a little bit further. So they thought about, how about to be basically have, this is a paper from Berkeley, you can have route LLM, which is have a router that decides what model to use. Instead of first using a model, you basically have a router that can automatically decide. And it also showed very promising results based on that, and saving over 2 times of cost. And then there's semantic routing. So today we're going to be covering a version of semantic routing through an AMD-born project that's called Lemonade, and they have that baked into their system, and it runs on local systems such as this one. The idea is very simple. You basically have an embedder that embeds that request that comes in there, and it tries to classify based on that vector that it produces, whether this is a better fit for model A or B based on the rules you define. And it uses similarity, such as cosine similarity, to figure out what that model is going to be. A very quick little intro on OpenClaw. OpenClaw is a much bigger project, but if you've never heard of it, it basically got super popular earlier this year. It is known as the most popular open source software out there right now. It's basically your agentic runtime. I believe the founder is also in this conference. Maybe we can meet him later. But OpenClaw, for what we're doing today, is we're using that very simple agent creation. And we created a few agents for you guys to play with. You're going to see that momentarily, how you can actually have those routing techniques that I talked about exercised through OpenClaw. The quick thing I want you guys to know that every agent you create has its own workspace. Those workspaces have a bunch of MD files, configuration files that you can use. So SolMD, for example, is one of them, agents.mds. Another one, OpenClaw.json, is that all configuration for the models, which models you use and what permissions you have. And we're going to be creating, well, we already created them for you. For example, the local brain agent that you're going to use is connected to a local model. The cloud one is going to be a cloud Kimi model that's running on a cloud. And a smart router is going to be how we can actually create a router ourselves today in a workshop. So we're going to cover 4 different kinds of routing. The first one is, I think, anybody who's using Claude Code or any sort of coding agents, you probably know that you can just do /model and change. That's the simplest one. But we progressively get a little bit more difficult. How you can have a dedicated agent for each model, or you can have automatic routing. So one agent decides if that task needs to be escalated to the bigger model based on the rules you define. And then semantic routing, which I covered briefly. So we have that in Lemonade, and Satya is going to cover that. Okay. The setup for the workshop is going to look like this. You have a virtual environment. So if you have that piece of paper in front of you, it's a good time to maybe log in right now and make sure you're logged in and can access that. There is going to be AMD Ryzen AMX 395 Plus for running that local model using Lemonade. And then anytime you need to escalate to a more frontier model, we're using Fireworks AI, which is running this model with AMD MI355 GPUs, and it's served on the cloud. The CPU on the system and the one you're going to be using, a little bit more about it. I think just want to highlight in terms of the unified memory, it has an iGPU, has a CPU, and has NPU. So together, they can actually run models pretty efficiently for you guys. 128 gigabyte of unified memory means that you can run models up to 200 billion parameters at a lower precision than 4 and be able to serve your models locally. This is the box that I'm showing. This is a small form factor of this that you guys can purchase and use as your always running agent host. Lemonade, we have one of the founders of Lemonade actually sitting on the side. If you want to have a chat with him, Krishna. This is, again, something that was born in AMD to be able to have a way of running models locally very fast, so you can basically just download with a desktop app and you're good to go with downloading models and running them on AMD hardware. More about Lemonade, I encourage you guys to maybe scan the QR code, take a photo if you want to get engaged in the community. And we should get directly to our workshop. Maybe switch and then we can display this on the site. Can I actually see show of hands? How many of you guys are actually connected to the instance and you have it up? That's great. All right, quite a few of you guys. That's great. Okay. So it's going to look like very similar to what I have here, right? So you basically should have a little side notes for you guys. That's this cover and story. So we're going to go through the story. So first is maybe you click on the story side on the right side. And then you should be able to see all the instructions that we're going to follow today. Just very few beginning points that I need to mention here are we're going to be switching between the terminal and a browser. If you never touch the terminal, don't worry, you can still finish this. You literally just, there's buttons that you paste commands in there, okay? So, and if you do need to have access to maybe came late or you still need it, please put your hands up. Ida can help you. Okay, and if you ever fall behind, we've made it very clear. You can just basically follow the story, but I'm going to be going through this with Satya. We can follow along. So first, in terms of terminal access, we have instructions here, but anytime we say go to a terminal, you basically need to have only a few open. Don't open every time a new terminal. Just keep the ones that you have open already and switch between them. When I say new terminal tab, so first of all, terminal you can open from application, right? Application, terminal, emulator, that would open this terminal. If you say open a new terminal tab, that's when you actually have this little plus button here. You can press that and it will open a new tab. And throughout the workshop, we have these bands to make it super clear for you guys so you don't get lost. That, you know, this next prompt, you're going to be switching to browser, or you switch to terminal, or open a new terminal tab. Start a new OpenClaw session. You're going to see how we're doing that. It's basically going to be in the terminal, and we just type OpenClaw space TUI, and that should open it. And then inside OpenClaw TUI, you already have your agent there for you to be able to talk to. And that would be basically what it is. One thing you should probably avoid doing so is copy pasting. This is an emulated machine, so you can't just like use your mouse to copy paste, so avoid doing that. It's not going to work. That's why we have these buttons. So the very first thing you want to do is just have one little hello world with the agent, make sure everything is working, and then we move on from there. That is introduction. So we're going to do OpenClaw TUI session workshop. If you just literally have the cursor, like the one I have, and just paste command. Anytime you press paste command, it pastes where the cursor is. So if I just do this, you should be able to see that it pasted in terminal, and you should be able to access your OpenClaw environment. It's great. It's up. Basically saying hi. Let's say hi. Make sure it's working. Hi. My name is Maddie. Great. So a few points here. Throughout the workshop, if I say like we're on this agent and you kind of got lost, you could see the agent is main. We have a few agents set up for you guys. We're going through them quickly. But as of right now, this agent main, to switch between agents, you still like, if you follow, you don't need to do it. But in case if you get lost, if you just do /agent and press enter, you should be able to select. Okay. And just like follow along. If I say, you know, I'm main agents, make sure you're on the main or switch between them. Oh, I just was notified that some people maybe couldn't log in earlier. There's more allocations now. If you couldn't connect to this environment, just refresh your page, and it should be able to connect. Okay, the very first way of routing. I mentioned that we're not going to spend much time on it. Any agent you have, if you actually have a bunch of models in the OpenClaw JSON added there, all you have to do is /model, or just paste this command that I have here, press enter, and you should be able to see all the models that we have ready for you guys. You can switch between them, right? For now, we're going to start with the Fireworks model from Kimi K 2.6 on Fireworks. Enter, that should be it, okay? I already did my hello, I'm one step ahead, but if you're not, make sure you introduce yourself before we move on to the next part. Okay, now we're on page 2. There's going to be 5 pages here, page 2. We're going to switch to a browser to start that Lemonade server that we have for you guys to be able to track any sort of server logs. So basically, if you have the browser open, you should be able to just basically copy this thing here. So localhost 13305, or just paste URL, press enter, it should come up. And then we're going to switch back to the terminal. So you should be able to see up here that I actually have the terminal. These are the tabs I have open. So if I go on the terminal and I open a new tab, as it says here, open a new terminal tab, just open new tab, and we're going to paste this command. So what this command is doing is basically tracking your last little prompt to see if it's running on the cloud or what model and what kind of like approximate cost could be. So we've done this for you guys to be able to kind of like switch back and forth between terminals if you're interested to see like, what model you're using, how it's routed, and what the cost is. Plus, on the very end, the challenge, you'll be relying on this to report how much you spent on your tokens. Okay, going back to your OpenClaw TUI session, I believe. Let me make sure I'm following right. Okay, first, act number 1. That's where we are, local versus cloud brain. This is a scenario that I want you guys to think about. Like, first of all, so I showed you guys that we do, /model to switch between models. But there might be reasons that you want to actually have a dedicated agent. So I'd say, like, I want to have one agent to always be running my local model, and one agent to always be, cloud. Can someone say like one of the reasons why I want to do that? Like, why would I even want to like have that dedicated agent? Personal data, that's correct. And the reason that maybe you couldn't have, the reason that that main agent wouldn't work, to expand on what you said, is you can actually set rules for each agent. So right now, I want to set the rule for this agent that don't ever touch my personal files if you're a cloud agent. So I want to disable that. If you use one big agent, you can't go set rules like this. It's going to be a lot more difficult. So one of the reasons you want to have this a local versus cloud agent to separate the agents completely is that you can set the rules, you can set permissions, and also create the context that is more suitable for that model. So here, to do so, it says open a new terminal tab. We're going to do that. And you're going to paste this command. So all it's doing is basically going through the list of agents I have. It finds that cloud agent and make sure that I disable the permissions to access the local files. Next, you need to restart your OpenClaw to make sure this is picked up because we changed this JSON config file. So again, on the same terminal that I just paste this command, which is OpenClaw gateway restart, press enter, and you should be able to get messages similar to what I have, that gateway is restarted and it's ready to use. There we go. And I'm going to go back to my first terminal, which I had the OpenClaw TUI. So this says start a new OpenClaw session. You can either do a new tab or just go back to the first one I had. Control-C should kill it. And if you just go up or just type this, OpenClaw TUI session workshop, same thing. It will bring up the TUI. Okay, here I want you guys to switch to, actually you are already on the Cloud Brain. So if you are not on the Cloud Brain, you should do agent and then go Cloud Brain. Or just paste that command in your OpenClaw TUI. So you should be able to see something like this that says agent Cloud Brain. Here's the agent that we just disabled it from running the files. So let me just reset my context from last run that they had here. Okay, So basically here I have a prompt ready for you guys. I have a file on the system. I want to make sure that it works. It doesn't access that file. So if I just press enter, and it says read the content of this financial.csv file, since we disabled the services, it shouldn't be able to access that. And you can see that it gives me, hey, I don't have access to the local file system, and therefore I can't do it. To switch to your local brain, that is another agent we have that is dedicated to that local model. Very similar concept. I can maybe skip this for the sake of time, but if you just do /agent local brain and type the exact same command, then you should see that financial report is actually printed and it works fine. So this is just to show you guys how you can have two different agents, one of them with set permissions to not be able to access your local file, and one of them does. Okay, I'm gonna skip 1B. As I mentioned, it's basically the same thing, but you get the idea. So we're gonna go to page number 3. That's Act 2. This is where we're gonna start doing a little bit more automatic way. So far, you were the router. So you were the one that picking which model to pick based on your need. Now, in OpenClaw, there is a way that you can actually set it up in a way that you always route to one model, and you actually ask that model to tell you if this should be escalated to the cloud model. And that's what we're gonna do next. So to do so, if you remember, I mentioned that OpenClaw has those config files. So switching back quickly to this slide, just make sure we're following. So we just did this part, which basically you have a cloud brain and that has its own config files and local brain, and you can set permissions. Next, what we're gonna do is create a smart router way of doing things, and we created the agent for you guys. So what we're gonna do is basically add a bunch of rules in that main agent sol.md file that basically tells it, for these rules, I want you to escalate to the cloud model, or for these rules, just use local. And that's as simple as that. Going back to my workshop tab. So if you just switch, actually before that, I want to show you quickly what the rules are. So we're going to do one more new tab. So I basically have four tabs total. And if I just paste agent /agent smart router, oh, sorry, no, the first one I'm going to do. The genome text editor, this is the one that we're doing right now. Open new terminal tab. So genome text editor, we paste this, press enter. It should open that sol.md for the smart router agent. So very briefly, every time I'm gonna ask this agent to work, it's gonna do this. Every single response must begin with exactly one of these two lines. It's either cloud or the local. So the classification should follow with some rules. The rules I have for it is, for example, if I'm asking you to write a code, use cloud. If I ask you to read a file, use local. So these rules are going to be followed by this agent automatically, so I don't need to every time select what model I want to choose or what agent I want to choose, and you can have a more automatic way of doing so. Okay, we don't need this. This is just for your information to see where we changed this, where we had it. The last thing is, just the point is, the way it's going to work if it's going to escalate to the cloud model, it's actually going to create a sub-agent, and that sub-agent is going to have that cloud model, and that's all configured through this sol.md file. Let's close these, go back to our terminal, and I believe this is where we switch to the smart router agent. So if you go here, /agent, go to smart router, and it should be open for you guys to use. We're going to do 2 simple prompts, and then we're going to move to Satya's part, which is the semantic routing part of things. So first prompt I want to show you guys is something that we should see it's happening local, but you should be able to see how that happens. So what does a 4-year vesting schedule with a 1-year cliff mean? Because in the rules I don't have that set to go to cloud, and the local model should be able to handle. You could see that the very first thing we get from here is classification. This is a local model, and therefore it's going to basically go and use the local model to respond to it. This will take a few seconds as if it's going through all the full thing, but yeah, so here we go. Classification local, it's a straightforward factual question, so I'm just going to use my local model, and therefore I got this. The very last part for me before I move on is just to show you guys another prompt that based on the rules that's following what we ask. So we ask it to, if you ever ask to write a code, it should escalate to the cloud model, and that's what's happening next. So if I say write a Python function to calculate loan interest payments and press enter, since this is writing code, you should see the very first thing it says is classification cloud, so it's going to direct to that fireworks model. And behind the scenes, how OpenClaw works is they're going to create a little small sub-agent, pass it all the context, say session spawn, go do this, then it waits for the agent to come back, and once it's come back, you get the results. This is going to take a few seconds to complete. If you don't get it, you can always just this is one thing that with OpenClaw and agents, you can always boolean it. If it doesn't do something or you want, you can actually ask us hey, what happened to the results, or what did you do this, or change your config. So here, if you don't get the results within a minute or two, you can just always go hey, what was the final result? Well, it's time for me to pass to Satya because he's going to cover more of Lemonade, and he's in that team that also worked on Lemonade, and they have that semantic routing baked into it. So I'm going to ask Satya to continue with this workshop. Thank you.
Thanks, Mari. Hey, everyone. So far, we've seen how to hard code OpenClaw configuration files, to help us with our routing. But in this section, we're going to see a more automated setup through Lemonade router. So before we start the hands-on part, just a quick graphic on the system architecture, how this section basically works. So what we have here is a simple setup where you send a prompt to OpenClaw, and it first goes to Lemonade router running locally. And the Lemonade router decides where to send your prompt. So if it's a sensitive question, it goes to a local small model, or if it's a complex question, it goes to a cloud model like Kimi K2.6. Or if it's a complex question that has sensitive information, it goes to a local, slightly larger model like Qwen 3.635b. Now, moving on to the hands-on part. So in this setup, we have defined some skills. So these skills are nothing but where you point your data sources, output expectations, and input guidelines, like how the skill has to work. Basically, we're instructing OpenClaw on how to handle the data or the question. So in this section, you guys are managing a startup where you have where your role is to handle employees onboarding, leaving, answering questions on benefits data, finance questions, legal questions, etc. And we're gonna do this using a set of skills. The skills are defined inside OpenClaw's skills folder. These are all pre-configured. If I just open one of them, it's just a simple guide for OpenClaw that this is where you get your data source. You're authorized to do certain tasks. You shouldn't do certain tasks. So that's just a quick summary on skills. Now, go to a new terminal, and then let's start a new OpenClaw TUI session for this part. And the first agent is HR admin agent. Let me reset my instance. Yeah. So we have employees.csv data. Basically, it has a bunch of PII sensitive information, personally identifiable information like SSN, email, phone number, etc. Now we're gonna switch to Fireworks, our cloud model, and then ask a simple onboarding question. So as you can see, this is where I'm tagging the skill, the HR admin. If I go back to my skills folder, this is where the skill.md file sits. And I'm going to ask my cloud model to onboard an employee. So to look at the data, this is where we have all the data. This is the employees.csv where the cloud model is currently writing to. So if I open it, as you can see, the Jordan Lee employee got onboarded. But what's the catch here? We just exposed a bunch of sensitive information to a cloud model, right? Now, the alternative here is to use a local model, but how can we automate this? We don't want to switch for every question, right, between a cloud and local model. So in order to do that, we'll be using the Lemonade router. So I'll be selecting the HR admin router from the dropdown. You do /model and then select the user.hr-admin router. Now I'm going to ask a similar question, this time onboarding a different employee, Maya. Let's see. So if I go back to the Lemonade dashboard, you can find it at 13305. And as you can see, the local model got loaded. But the reasoning behind this is you can expand Lemonade router and then click on the gear icon next to HR admin router. And this is where you have the basic LLM-based routing. So you select your candidate models. In my case, I've selected a cloud model and a small local model, Qwen 3.69b. And then my natural language and my router LLM is, again, Qwen 3.59b, which decides where to route this question. So the routing prompt is like very simple. If you see any personally identifiable information, send it to a local model. For anything else, just send it to a fireworks model, right? Now going back to my TUI, yeah, as you can see, yeah, I think it's got it onboarded. No? It's found some inconsistencies in the question. Okay. Oh, okay. I forgot to change the date, but you get the idea. Like it is supposed to go and write the data. If I change it to first. Okay. Yeah. So in this case, we have like 0 data leaving our machine, and all the data is staying local, along with the routing. Now, while that is running, you can see the Lemonade logs running in the backend, where you can see the TTFT, TPS, and other metrics for this local model. Now, for the second part, yeah, looks like it is done. Let me close this. Yeah, so got onboarded the new employee, and this is done using a local model without any data leaving the machine. Now, moving on to the second agent, our benefits agent. This is a simple, the agent's goal is to perform RAG on a set of data sets. In this case, benefits handbook.markdown. Now, let's directly switch to the Lemonade router instead of going to a cloud. I'm going to select user.benefits router and then ask a simple RAG question. So if I go to the router and then expand the benefits router, so this is where you define your keywords, regular expressions, and whether your input has images or if there is any tool calling. So these are the set of rules that I've defined for this agent. And this question has, the question basically is asking, when does my 401k vesting cliff happens? So this goes to a simple benefits RAG rule. And if you click on expand in advanced, the same quick rules gets expanded to the advanced rule section. And if I go to the simple benefits RAG, I have the keywords defined here. So if you see any question on 401k or vesting, or if the question is if the question is below 400 characters, route it to a local model. So that's what happened just now, and the question got routed to a local model. And we also have a bunch of other rules for PII and complex queries. I'm going to cover them later. As you can see, we got the response from the local model, and we didn't spend any dollars on a cloud model for this simple question, right? Now, I'm going to ask a slightly complex question. Again, a local model can handle it, but I want to show the difference between the routing scenarios. So now, this time, it comes under complex benefit analysis. As you can see, if I'm asking questions about comparison, analysis, data analysis, etc., or any benchmarking related questions, or if the prompt is longer than 800 characters, send it to the Fireworks Kimi K2.6 model. So now, the Fireworks model has answered the question for us. And we didn't have to switch between different models, right? The router took care of all of that routing. And moving on to the third agent, the finance agent. So again, the agent's goal is to perform data analysis over CSV files. These are like a bunch of example CSV files with dummy data. Now, moving on, let me select the finance router, and then ask a simple question about the burn rate. Like, what is our current burn rate? Now, if I go to the finance router, so this should open the advanced rule section, and we have defined different finance-related topics here, and we have a semantic similarity type selected, and we also have like classifier LLM-based routing. So we are using a simple embedding model. What it does is it performs a cosine similarity between the concepts that we defined here and the input prompt, and then it gives us a score of 0 to 1, and in our case, what is our current burn rate maps with simple lookup. And if I go to my simple metric lookup, I defined my label here out of all the 3 labels available. And if the threshold is greater than 0.6, route it to a local model, right? So yeah, so we have our local model answering this question. Now, moving on to a slightly complex question where we're asking about multi-source analysis. So this time it goes to deep modeling, and yeah. So if I go back to my finance topic, deep modeling concept, and this is where I defined some examples. I didn't put the exact question here, but a bunch of questions that kind of summarizes my input question. And I also defined another label, this time an LLM doing my routing or classification between if it's a complex question or a simple question. So I've asked an LLM, like Qwen 3.59b, to classify my question between complex and simple. And if it says, so if either of these 2 rules gets kicked in, that's when the cloud model fires. So in this case, if the complexity label gets more than 0.5 threshold or label, then it goes to cloud model. Or if it's a semantic, if the semantic model, embedding model gives rating more than 0.72, it goes to in this case, as you can see, deep modeling, it goes to a cloud model. So now this question got answered by a cloud model. Yeah. So that's it on our end. We have a challenge for you guys, and the QR code should take you to a form. We have some gifts. So if you can solve this task, I don't know how long we have. There may be 10 minutes or so. Just let us know. We're tracking these scores, and you're supposed to use the lowest amount of tokens possible to solve this task. You can use a local model, or you can use a cloud model. You can also use Lemonade router, or just use plain routing, up to you. And these are the gifts.